Let's look at number 1 from the try of these, evaluating limits. We are asked to evaluate this limit without using a calculator. So the first thing I'm going to do is I'm going to substitute 4 in for x values in the numerator and in the denominator. Now I'm just going to do some simple algebra here to evaluate the numerator. I know it's 64, subtract 32 is 32. 4 minus 4 is 0. 32 subtract 92 is a negative 60, and negative 60 plus 60 is 0. So I'm left, when I substitute in 4, with 0 over 0. What does that mean? That means we have a hole in the graph. We need to figure out a way to go up and to factor the numerator. Now, when I first glanced at this, my thought is, can we factor by grouping? We cannot. So we're going to go back to synthetic division to help us out. I know I want to factor out a group of x subtract 4. So if I'm factoring out an x subtract 4, when I plug it into synthetic division, I ask myself what subtract 4 would equal 0, and the answer is 4. So I'm going to put a 4 out front, and now I'm taking each one of the coefficients here and placing them into the respective places. Bring down the very first number. Remember, everything comes back to here. So after you bring down the very first number, we're going to go ahead and we're going to bring down the first number, which is 1, excuse me. I'm first going to multiply, then I add straight down, multiply, and add straight down, multiply, and add straight down. You may recall me naming this MAMA method last semester because we multiply always followed by add. Multiply, add, multiply, add, multiply, add. When you get a 0, you did it right. So now I can come back up to this original function, and I can write one of the factors is x subtract 4. The other is 1x squared plus 2x minus 15. If I factored all of this out, if I distributed the x and the negative 4, combined like terms, this is what I would end up with. Now, why did we do that? We did this to help us, allow us to evaluate this function as a limit approaches 4. Now, when I simplify, I'm left with 1x squared plus 2x minus 15, and now I can substitute back in with 4. Okay, so I substitute a 4 into each of those positions. I know 4 squared is 16. 16 times 1 is 16. 2 times 4 is 8. 8 and 16 is 24. And 24 minus 15 is 9. So if I come all the way back up here as I evaluate this limit as x approaches 4, I know the answer is 9. The first thing I'm going to do is I'm going to start by taking 0, the provided value, and I'm going to substitute in wherever I see an x. And by doing so, I can say I get 0 over 0. So what does 0 over 0 mean? It means there's a hole in the function. We need to find a way to factor out something. So I want to factor out an x. Remember, this is really like 1x. So let's figure out, if I could factor out an x here and rewrite this function, it would look like this. I have 1x on top, I have an x in the bottom. 3 times x is 3x squared minus 4. Why did I do that? Because now the x on top and the x on the bottom are going to simplify to 1. So I have 1 over the quantity 3x minus 4. And now when I substitute in the 0, I have 3 times 0 minus 4. Well, 3 times 0 is 0, and 0 minus 4 is negative 4. So 1 over negative 4 would be the answer as you evaluate this function as it approaches 0. Let's look at number 3. Again, to evaluate without using a graphing device, I'm going to take it and I'm going to substitute in 4. 4 squared is 16, minus 4 minus 12. 4 minus 4 is 0. 16 minus 4 is 12. 12 minus 12, I have 0 over 0. Again, I have a hole in the graph. I have to find a way to factor. Now, I recognize that this can be rewritten as negative x plus 4. So let's factor out a negative sign. I'm going to rewrite the denominator as negative 1 times the quantity x minus 4. If I distribute the x, I still get a negative x, and I get a positive 4. Now on the top, I'm going to factor this into x subtract 4 and x plus 3. Over here, what multiplies equals negative 12, combines equals negative 1. That would be 4 and 3. Again, different signs, a larger number being negative. That's why I have a negative 4 and a positive 3. These don't just disappear, they simplify into 1, and I'm left with x plus 3 over negative 1. All right, now it's time to take that 4 and substitute that 4 back in. 4 plus 3 is 7. 7 divided by negative 1 is, in fact, negative 7. If we evaluate this original function at 4, as the limit approaches 4, we get an answer of negative 7. Number 4 from the try these, evaluating limits. So when I look at this again, I start by plugging in 5. 5 minus 1 is 4. The square root of 4 is 2. 2 minus 2 is 0. And 5 minus 5 is 0. We have a hole in the graph. We have to find a way to rewrite this in equivalent manner. And I don't think this is going to be factorable. What I do know is I can multiply by the conjugate of the numerator. That means I'm going to take the numerator and write it exactly like I see it. But instead of having a subtraction sign, I'm going to put addition sign between the two groups. All right, so let's start now by thinking about foiling the top. So when I take the front times the front, remember the square root of x times the square root of x is just x. Just like the square root of 4 times the square root of 4 is the square root of 16, which is just 4 again. So the square root of x subtract 1 times the square root of x subtract 1 is simply x subtract 1. And now if we multiply the insides and the outsides, they're direct opposites of one another. One of them is negative, the square root of x minus 1. The other is positive, 2 the square root of x minus 1. They're directly opposites. They would cancel out. So we only have to worry about the front and the backs. Negative 2 times positive 2 is negative 4. We have the top done. Let's look now at the bottom. I want to take x minus 5 times this quantity. Oh, this is starting to get ugly. Okay, so let me reposition this so we have enough room for everybody to see. Okay, so I'm going to have x minus 5 times this quantity. You know, before I take time, I'm not going to FOIL this out. I'm going to leave it as the quantity x subtract 5 times exactly what I see. And the reason for that is if I go ahead and take off the parentheses and I combine like terms, x minus 4x minus 5 is the same as x subtract 5. And now I have a quantity x subtract 5 on top and x subtract 5 on the bottom. When you simplify these, they don't just disappear. Remember, they simplify into 1. So I'm left with 1 over x minus 1 plus 2. And now I can go in and I can substitute in a 5 to evaluate this original limit. Here we go. 5 minus 1 is 4. The square root of 4 is 2. And 2 plus 2 is 4. So when I evaluate this, I'm left with an answer of positive 1/4. All right, so if I substitute in 0, I end up with 1/2 minus 1/2, which is 0 over 0. Again, all the examples we're going over right now, we're ending up with 0 over 0, or a hole in the graph. If we ended up something with a number over 0, for instance, like 4 over 0, remember that would be an example where we would have an asymptote and the answer would not exist. And if we were able to plug in the number we're provided, and we actually came up with a numerical value right away, well, then we have our answer. So everything we go over right now is kind of the trickier problems. So again, I just went over plugging in 0. I know I get 0 over 0. Let's see what we can do. I'm going to try the butterfly method up top. So 1 over 2 minus x minus 1/2. So 1 times 2 is 2, and 1 times this quantity is 2 minus x, all over 2 times the quantity, 2 minus x. Okay, I'm going to distribute. I get 2 minus 2 plus x over 2 times the quantity, 2 minus x. Okay, 2 minus 2 is just 0, so 0 plus x is x. So I have x over, and there's 4 minus 2x. So x over negative 2x plus 4, I guess I could rewrite it as. This is my numerator, and the entire thing goes over the denominator. I'm going to write this as x over 1. So my numerator is x over negative 2x plus 4. And now I want to divide that by the denominator. Remember, when we divide by fractions, we really multiply by the reciprocal. And the whole point of doing all of this is so that we can rewrite it in a way that allows us to simplify or cancel out. So I'm able here to simplify the x's, and then I have 1 over negative 2x plus 4. So I have just taken this original function and I've rewritten it. Now when I plug in 0, so I substitute 0 in here, negative 2 times 0 is 0, and 0 plus 4 is 4. I have 1 over 4 when I evaluate the function as the limit approaches 0. Okay, number 6 from the try these. I know that every problem we've gone over, I'm plugging in this case, a numerical value of pi, and I'm getting 0 over 0, right? So we know that. But I already went over in the last problem. If we didn't get that, we would either know we have the answer, or we'd have an asymptote in which it does not exist, the answer. So let's go ahead now and let's rewrite tangent as sine over cosine. And then we're going to divide that by the sine. We can write sine over 1. When we divide fractions, we're going to take the second fraction and we're going to multiply by the reciprocal. And here we go. The sines, again, are going to be eliminated because they simplify to 1, and I'm left with 1 over the cosine. All right, let's look here. Let's evaluate the cosine at pi. Remember CBS, cosine before sine. So at pi, the cosine is negative 1. So I'm able to replace this when I plug this in with 1 over negative 1. And I know 1 over negative 1 evaluates just to simply negative 1.